Welcome to this tutorial. Today I'd like to talk about creating native JDK9 applications. And the reason why I'm mentioning JDK9 specifically is because JDK9 introduced the Java Platform Module System. And that means that the JDK itself and your application can be modularized. And for the size of a self-contained application bundle, this means that you only need to ship the parts of the JDK or JRE that you actually use in your application. And that makes a really huge difference between a Java 9 application and a Java application prior to JDK 9, because the whole JRE or JDK can easily be hundreds of megabytes in size. And if you want to just ship a small GUI application, let's say you're building a JavaFX application, then you can probably get it down to something like 50 megabytes, which is really a huge difference. And you still have a lot of dependencies, so you still have WebKit and stuff like that within your application bundle as dependency. And if you compare that to something like Qt, for example, then you easily end up with an application bundle between 50 or 60 megabyte if you ship WebKit and like their Chromium integration. And yeah, so I think this is really a reasonable size for like a real cross-platform independent application bundle that doesn't rely on installed JDK versions. Yeah, and the way we will do that today is we will just use the default tools that come with the JDK. So we are not using any special Gradle plugins and stuff like that to package our application, but we'll just create Gradle tasks within a standard Gradle builds file to execute those commands. And we will make use of Java Packager for creating the native launcher and integrating the JRE. And then we will use JLink that is capable of producing a specific runtime that only contains the dependencies that you need for your application. So it further optimizes the file size of the JRE that we ship within the application bundle. And that makes an application bundle roughly 50 megabyte in size. And if we compress it, it might be something like 30 megabytes or something. And you can ship the application. You don't rely on system-wide installations of Java. You don't have to tell your users to use a specific version. You just ship the application, and it has a native field because it has a native launcher, which is also important if you want to add your application to app stores like the Windows App Store. Then you actually need to have a native executable, and you cannot just use a launcher script or something because this is not allowed. Yeah, I'd say we just start right away and have a look at the source code. Okay, so here we have the source code, and it basically consists of two files. First, we have the main.java file. This is our main class. We extend the JavaFX application class, and this is JavaFX specific, so we implement the start method, and we can just leave out the public static void main method. Of course, we can do that and use the launch method if you're familiar with that to just be backwards compatible. But this is the right way to write a JavaFX compliant application class. And what we then do is we create a button and we set just some action. So here we just show the current date as our stage title. And then we do the obvious thing, like we create a stack pane as root pane and put the button into the pane. And then we set up our scene and finally the stage. So we set the stage title and the scene, and then we show the stage right here. Okay, so and then we have the build.gradle file. So in here, we just use the Java plugin, which is really straightforward, and it's a standard dependency for Java projects. And really important is that we specify our source compatibility and also our encoding options. And in here, we also use the Gradle wrapper. And okay, this comment is just wrong. So it's version 4.5. that we use here. It works great with the current JDK9 release, and of course in the future this might change, so you probably want to stay pretty bleeding edge, because Gradle is still a moving target. It adapts to the new modular style of Java. So you should always look at the Gradle documentation and try to use a fairly recent version of Gradle, otherwise you might get into trouble. So let's say you watch this video at a time where JDK 12 is available, and then you probably should upgrade to the newest Gradle version. Okay, so then we specify a couple of things, like we specify the JDK folder. So we get it from the system property java.home. And then we also specify our module name. And the module name, we just derived that from the package name. It's rather lengthy, but it ends with Native JDK9 App Template. And then the main class is Native JDK9 App Template .main. Okay, so and then in the Java manifest file, we just specify the main class here. Okay, so we will look at the actual Java packager tasks later. First, let's just try to execute this application. So we just go to this directory, and inside the Gradle project directory, we call the assemble task. And now we get a just a jar file, so no runtime, no bundle or anything. But we should be able to just call it with java-jar. And this is usually in the libs folder. So this is our application. I can just click here, and we see the date appears in the title of the stage. Okay, so the application works. That's great. So now let's have a look at the Java packager task. The Java packager always ensures that the project is assembled. So that's why it declares a dependency to the assemble task. So we always get a jar file, even if we cleaned the project or something else. And it is of type execute. And here we can just specify a working directory. In this case, it's just the project directory. And then we can specify our command line arguments. And this is, we invoke the Java packager with the deploy option. We do not sign the package. It should be native, a native image. And then we specify the output directory, which is distribution inside the build directory. And we also specify an output file name, and it just derives from the project name. And of course, we also specify the main class, and we specify the module path here, and we use the path separator to ensure that it works on all operating systems. And of course, we add our own module that we just created, and then we specify our main class. It's a combination of module name and main class name. Okay, so far so good. So this is just, we call the Java packager. We could have done that from the command line, so there's no fancy plugin or anything. Before we do that, let's just have a quick look at the module info.java. In here, we require the JavaFX base package, graphics, and controls. And of course, we export our package. This is important because JavaFX, like the launching class, wouldn't have access to that otherwise. So this is important to have it here. Otherwise, the app won't start. Okay, so That's it. So we're not going to cover like the platform module system itself. So this is about creating the bundle. If you are interested in that, we might give you some pointers, or you can ask in the comment section below. I think we should just try to call the Java packager task. So this will just take a while. It will package the jar file and the runtime into a bundle. So here it says the result application bundle is in this folder here. So we might just cd into it. Okay, so in here there should be a native JDK9 app template folder. Okay. And in here is an executable file on Windows, and yeah, the same is like for Linux. You get also a native launcher, and for macOS you even get a nice application bundle. So this is our application. So this is really a native application. It has a native launcher, and also, yeah, it allows distribution through various app stores and so forth. So now about the file size. I mean, this is something that you can read up in the documentation. Like, fine, you got a JavaFX application with a native launcher. If we do that, we can clearly see that the runtime is rather large. So this is the content of our native JDK9 app template folder, and the runtime is about 88 megabyte. And here we have some DLLs on Windows, which aren't too big, and they don't add much, but I mean, you have to ship them anyway if you want to ensure the app runs without people manually installing the Visual Studio runtime dependencies and so on. And you might have dependencies like that on Linux and Windows, Linux and Mac as well. But the most important thing is that also the executable itself is pretty small, and all the other contents are, yeah, we can ignore them basically. But the runtime is really huge, like 88 megabyte for just a tiny application is really too much. So what can we do about that? Yeah, I mean, we can try to improve our runtime image. So, and that's why I've created a task, create final app bundle. And it's also of type executable, and it depends on clean packager runtime. So we just throw out the runtime part, but we leave everything else. And this is just the task here. So inside the build directory, we just delete the runtime part here, but we want to keep the actual launcher, like the native JDK9 template executable. Yeah, and the jlink command that we use here is much better at reducing the runtime than the Java packager, even though the Java packager gives you some options. So we saw like 88 megabyte isn't like the full distribution size of the JDK or JRE, but still too large. Okay, so what we do here is we also specify the module path. So this is like the inside the JDK folder, the J modules, and of course our own library folder. And we add our module here. And we strip the debug information. So this is important because we ship a production application. We don't need this. Also no header files. Nobody's going to use our runtime and builds stuff with it. And they can just download JDK themselves. There's also, we don't need manual pages. I mean, on Linux or Unix in general, you might want to keep them, but for a GUI application, we actually don't. And also we strip the native commands. So even the Java commands and all the other Java compiler, if you have a JDK, won't be in the runtime bundle because we don't need them. I mean, there's no way. It's there's no reason why we should actually keep those commands. They're just confusing. And here we specified that we use the server VM. We could choose the client VM. And that's just what I usually use. If you have a GUI application that runs for a longer time, I get better results with server. But for such a small application like we show here, you might actually switch to the client VM. So you can test it out and use the one that fits your needs best. Of course, we do compression. So we actually compress the runtime. And then we specify the output folder, which is basically the same folder that we deleted up here. Yeah, and in the end, we just show the location where the actual distribution will be after the build process. Okay, so let's try that. So instead of the Java packager, we will use the create final app bundle task to produce our bundle. And it will also go through all the stages that we did before. Like it will assemble, it will do the Java packager thing, and then replace the runtime. So now let's have a look. So we go to the same folder, distribution folder, ls in here, and we see we have the native folder. We should be able to just run the application like before. Here we go. Works as expected. And now we should also be able to see a huge difference in here. Yeah, and we actually do. So this is almost half the size of the original bundle. So here we see it's 45 point something megabytes. And this is a huge difference. Like the original one was already a lot smaller than the JDK distribution size. And this one is like half of that. So that's pretty cool. So I think shipping such an application isn't much of an issue anymore. So let's do a du here. So the whole size is like 47.2.3 megabyte. Yeah, but I think 47.3 isn't huge anymore. I mean, it's still more than just a couple of megabytes, but you have to remember that you get a whole lot of dependencies already here. So like you could create much larger application than just this click one button application with the same dependencies. I think it might even be possible to optimize that a little bit, but I think at least for my applications, this is now totally usable. For this simple application, we won't create an installer or something. Actually, this is something that you can just look up in the documentation, because this is like a standard again. So if you have the bundle, you can use setup or other tools on other platforms. Like you could use the application bundle on Mac OS and RPM or Debian packages for Linux, and you can produce them with the JDK tools according to the documentation. But of course, we want to package the application so that we get a download size or something that we can estimate how many megabytes your users would have to download. So let's do a 7-zip native template.7zip or something, and then we just add this folder. So this takes some time. And after that, yeah, let's have a look. Okay. So here we are. So we got basically something like 29.3 megabyte is the size of the actual file that you download from the internet. And I think that's a reasonable size. So concrete. So a real shout out to the Jigsaw team, who did a really great job. I mean, and finally, A big thanks to the Jigsaw team. They did an incredible job at producing JDKs that are really modular, and I know it's a really complex topic. They weren't lazy. I mean, they worked on this for many years, and even though JLink and Java Packager, they don't really work that well together, I mean, it's pretty simple to fix it yourself. So we have a really nice solution right now for writing our own GUI applications. And personally, I really hope that we see more Java-based desktop applications, and like this becomes a thing again, because JavaFX is a really great toolkit, and now with distributing applications that are pretty small, I think there's no reason why you shouldn't do that. Thanks for watching this video. I hope you enjoyed it. In this video, you learned how to create native JDK9 application bundles with a minimal runtime footprint, and only by using standard Gradle files that should basically work anywhere. If you have questions, comments, or critique, then just leave a comment below. You can also find me on Twitter and of course on GitHub. I will publish the whole source code, the template project on GitHub, and give some explanations on how to build it. Yeah, that's it from my side. See you next time. Thank you.